Hi guys, today we're going to build a game called Bejeweled, or however it is pronounced. So basically it is another board game that has jewels, or yeah, they're jewels. So you can swap them, swap to adjacent jewels, and then you can get a chain of 3 or more in order for them to disappear and get points for that. And I think it's a timed game or something. Yeah. So basically we're going to do a very simple version of that. I'm going to create a new package for this tutorial and call it Bejeweled. And our application class, which is going to be called Bejeweled app. And we're going to extend JavaFX application as always. To use that, we'll need to overwrite a few things, like the start method, and finally we'll add our entry point, which launches the application. Primary state show, set our scene, we're going to create pane as our root node and return that, and import all of those things. So this is our sort of boilerplate code that we use pretty much every time. Now we need to have a board, or at least define how many jewels, I'll call them jewels, thingies that we'll have per row and per column. So W for width and 6. And for height 6 as well. We'll need our size, so size for each of the jewels. We're going to have 800 pixels. And by having this information, we can now set preferred size to our root node, which is W multiplied by size and height multiplied by size. So which gives us 600 by 600. There we go. Now we will need to represent our jewels somehow. So we're going to create a new class, jewel extends parent. We will need to create a circle. Yeah, we'll use circles with different colors in order to distinguish between them. And potentially you could use image views here and set different images like it really should be. Circle, so if size of one element is 100, we need to set radius size divided by 2, because the diameter of the circle will give us 100. We'll also need to set center of the circle to size over 2. Because by default the center is 0, 0, and you get you don't get what we need because of calculations that happen from top left. So basically almost everything except for circles is counted from top left, being the 0, 0, and circle, its center is 0, 0, so you get sort of minus offset, which we don't need at the moment. And that is it really. But we'll need a random color, so private. We'll create an array of colors. We're going to use a lot of them, just 4 or 5 will do. First import color, make sure you import JavaFX color. And in the array we'll define color black, color red, blue, green, and maybe one more yellow, so that they're more or less distinguishable between each other. Circle, set fill. So we need to obtain a random color, which we can do by calling new random. We need to import random first. Next int, it is bound, and the value that you pass is exclusive. So if we pass the color's length, so the length of the array, we'll get a value, maximum value of length minus 1, which is exactly what we need. And this should take a random index out of this color array and set that color to the circle. And because the circle is the only element within the parent, it basically sets color to the whole object, to the whole element. Now we will need to populate our screen with jewels. So I've already used grid method, grid technique in one of the previous tutorials, so I'm going to use Streams API in this tutorial. Streams are really cool, and many things can be done using streams. And I wonder if we could complete this tutorial using streams only. Alright, so we need to have, what, 6 by 6, meaning 36 jewels. So we'll take in stream. We'll need to first import the class. In stream of, we'll need range closed, 0 and inclusive, that's W multiplied by H, which gives us width multiplied by height and 36 elements. Now for each of them we will need to, first of all we need to alter the constructor to take certain point, and this is the point where we will be placing our jewel. We'll need to import point2D from JavaFX. And once we've given the point, we will need to set translate x to point get x multiplied by size, because this point will be essentially between 0 and 5. And hence we'll need to multiply by 100. So translate y as well. The thing to note here that we're translating parent, so the whole object, as a single object, not the circle within the parent, but the whole parent object. Because if you translate only the circle, this will sort of extend the boundaries of the parent, and we only need to treat the whole thing as one object, which makes it a lot easier. So set translate x and y, set fill, what else? I think that's it. So for each of those we need to map, I think, because we'll be producing points first. So we will take an integer out of this stream, which is going to be from 0 till 36. Actually, should be 35 probably. So So it's range, just range. And we're going to return a new point, which is I divided modulus division W. So if it's 0, modulus division by W gives us 0. And if we go over, that would be 6, modulus division 6 gives us 1. And that moves us to the next row. Yeah, that's correct. So integer division H. So this will essentially give us point at which we need to create this jewel. Now that we've mapped an integer to a point, we now essentially have a stream of points, which we now can use for mapping to jewels, so that when the whole stream operation is complete, we will get a list of jewels. Finally, we will need to collect all of those things, and we can collect all of those things to a list, collectors to list. That ideally should return a list of jewels. Oh yeah, right, map to object. We're going to import list now. And finally we get a rather long expression, but it should make sense. If we do it this way. So we've taken a stream of integers from 0 to W multiplied by H, which gives us 36, but this is an exclusive range, meaning the end is exclusive. So it's from 0 to 35. Now we are going to map each of those integers to a point, which gives us the position where we place our jewel. Finally, we map those points to jewels, where we obtain a stream of jewels, or a stream of instances of this class jewel. Finally, we collect all of those things to list, which gives us back a list of jewels already instantiated and ready to go. What we need to do now is add those things to the children of our root node, so they're displayed. We can do this by just calling add all, which expects a collection, and list is a collection. So what we get is essentially what we could have achieved using a nested for loop, so basically two for loops going from 0 to H and 0 to W. So now we have a we have jewels, which we cannot do anything on just yet. So the description says that we can only swap two adjacent jewels, but I'm not going to check whether they're adjacent or not. We're just going to implement a simpler version, which would be allow swapping any two jewels or any two circles. And we can do this by, so we'll need to have a reference to selected jewel. By default, it's going to be null because nothing is selected. When we so click, that would be set on mouse clicked. If selected is null, then that means nothing is selected, so we select this jewel, and if selected is not null, then something is already selected, so we swap the positions. I'll just call swap, and then we'll implement it a little bit later. So swap selected with this. After swapping, we need to clear the selected, so selected is null again. And I think that's it. Well, at least for now, that's it. Hard void swap, which takes jewel A and jewel B, and we'll swap them. Actually, we can. The only thing that determines what kind of jewel it is just its color. Well, in this application anyway. So what we're going to do is simply get one color and then swap the colors. This is pretty much the easiest way to do the swapping. Now you can't get the color directly. We'll need to have a method for that. Color get color. We'll take that and promote it to be an instance field rather than local. We'll then return circle's color, which is fill, and it's returned as paint. And we'll use paint, doesn't really matter. Paint is just a superclass of color. Get color. Set. We'll need to have a method to set the color. So it's a simple swap operation. We are remembering the color of A, we're setting the color of B to color of A, and then we set the remembered color to B. And this is the swap operation. So we click on one circle, then click on the other, and it swaps, well, it just swaps their colors, but the user doesn't know about it. So it doesn't really matter. Now we need to implement a little bit of logic which will allow the game to remove a line of jewels if they have the same color, and we'll award points for that. Now once we've swapped them, we will need to check it right here. So check state or something. And we will need to have access to the list of colors, or list of jewels, sorry. So that's list of jewels. So when we do our stream operation, the collected list will be assigned to the jewels, so that we could use that list later in checkState. And in checkState, we pretty much need to check vertical lines and horizontal lines, which we can do using streams again. Okay. For that, we will need to know each of the jewels row and column. So get column. Column is basically the x coordinate, yes. So get translate x, divide by size. And because we're operating with integers pretty much, because we're setting them as integers, it is fine to typecast it to integer and then divide, so we get a whole number anyway. So column is these things, and it will be determined by x, yeah. That should be correct. Get row will then be determined by get translate y, divide by size. Because essentially when we do checkState, we'll be checking all of the jewels that have the same column or row. And we'll do that using streams again. Alright, so list of jewel. Actually, jewels get stream first. We need to, what can we do? We'll need to collect them somehow. What kind of collectors do we have? Collectors, grouping, yeah, that should do it. Grouping by jewel, get row. And that returns map integer to list. Oh yeah, so the integer will contain rows. Okay. Integer list of jewel. Import util map. So essentially what we've done here is we obtained the stream to the list of jewels so that it will produce a stream of those elements within the list. We are then collecting these elements into groups, and the group is represented by a list. And those lists are grouped by getting or calling this function, which we're passing a function or a method reference. It calls this getRow, and if an element within the list returns exactly the same value as another element within the list, then they're grouped into one list. And then the key to the map is given by this value, which is row. So this will essentially contain 0, 1, 2, 3, 4, 5, which are our rows, and each of these numbers will point to a list which is going to contain elements from that row. Similarly, we can do columns. Jewels stream collect. Collectors grouping by jewel get column. So the double colon notation means that we're referencing the method. We're not calling it, we're simply pointing to that method, saying you will need to use that method to do something, and that something is grouping. Now we've obtained rows and columns. Now for each of the lists within, so a row is essentially a list, again, a list of elements. So what we have, if we don't take this into account, we have a list of lists. And we can obtain values from the map, which returns this list, or rather multiple lists, because we have several lists. That's 6 lists, and for each of the lists we're going to check if all of them have the same, if all elements have the same color. So we're going to have another method called checkCombo, which takes a list of jewels, jewels line, because that could be a row, so horizontal, or a column, vertical. We take the first jewel from that list, and at this point we sort of assume that there is at least one element, because if not, this is going to throw an exception. And then for, oh yeah, we're not using loops, okay. Jewels, line, for each. Use a stream, and then what? Filter. Filter if the color, so it takes a jewel, J, which are the elements of that list or stream, and then we're going to compare the colors. Get color. We can use the double equals notation or operator, because these are essentially pointing to the same objects, and hence we use that instead of equals, or rather we can't use that. Otherwise, if these would be new objects or different objects, you would need to use dot equals, which we can also use it here, but this seems nicer. Jewel get color. So if it's exactly the same color, or we can filter if it's not the same color, and then just count them. Count will return what number? Yeah, number of elements in the stream. So count. Okay, it returns a long. So if count equals 0, this means that all elements have exactly the same color. And what we need to do is, well, we don't have a score object yet, but this is where we would increment our score. So add score. And shuffle those colors again. And we already have a line of objects, so we can simply do jewels, line. We'll just create a new method here called Randomize, which will change the color to random color. So rechange, as it were. Circle set fill, and we'll use exactly the same, which will randomly obtain a color from this array. Jewel's line for each jewel, and we're passing a reference to randomize method, meaning that for each of the elements within the list, call this method on that element, or that element's method, to be more precise. And for each list check combo, we can't really do this because we need to refer to that method. So we can refer to the method within the same class by just using this to refer to the instance of this class, and by pointing to that method. And we'll need to do the same for columns. Let's try and see if that works. So we're swapping this, that, and that. And this has now changed all the colors. Red, red, and it randomized again. The last thing we need to add is a score, which we will, there's really no place on the screen, so we'll add 150 pixels to the right so that we have sort of some space. We'll need to create a integer property, score, new simple integer property. I'm going to import it, and we'll also need to create a text object, text score. Import JavaFX text, text score, position it, so translate x to w multiplied by size plus 100, actually no, just w multiplied by size, that's the x, top left x. Set translate y is going to be just 100, and we can then bind its text property to our integer property taken as string. We can even format it and do something like that. Finally, we'll need to add it to the root node. Yeah, we need to increase the font. It's very small. Font 68 or something. Alright, and finally here we will need to increase score, set score, get plus 8,000. It's actually too big. So here we go. Do this, we get 1,000 points. Do that. So we've done the horizontal. Now for the vertical, yellow, yellow, another yellow. So it works both ways. The only thing I can think of is that if it spawns as a complete line, it will not disappear and randomize itself, because this is essentially our game logic, which is only called when we do the swap. So if we're not doing swap, then automatically this will not sort of give you points and do the logic stuff. Apart from that, it seems to be working, well, mostly. yeah, as you can see, this line just appeared, so spawned as a complete line, but it did not disappear because of the logic not being executed. And if we redo the line, it will correctly register it. I think this will be enough for the tutorial. It was kind of a complex tutorial, especially if you haven't done anything on streams. So if you want to redo it, that's fine. Yeah, I'll put up a link to Oracle tutorials on streams because they're really nice things, especially when operating with lots of elements within lists, maps, and other data structures. Although you don't really need to do everything using streams. Just sometimes it's easier, sometimes it's not. Basically, it depends on what kind of thing you want to do and what kind of thing you want to achieve. If you're interested in tutorials, you can subscribe or just comment saying I want to see more of certain things. I'll try to make at least one tutorial a week and see how that goes. Alright, thanks for watching.